Hi, Ruslan. Hi, everybody.
Hi, Sergey. Hi, everybody. Thanks for joining.
Thanks, everybody, for joining. And well, we'll start in about 5 minutes. We'll wait for people to join us. So we are really happy to have Ruslan here, despite his recent car accident. It's very nice to have you. I hope you are fine. So how do you do?
I mean, it's like what doesn't kill you make you stronger, basically. So I'm more or less fine, and I think like we should, despite everything, we should try to have fun today.
Yeah.
I would like to say some words, but like when we actually start, like to like so everybody understands what's going on and what happened to me, and like to say some apologies, and yeah, but let's wait, everybody. How do you feel about the upcoming conference?
I think that will be fun. I'll be the guy introducing all the speakers, the monkey with the mic on the stage. Never did it before, but apparently eventually all the engineers turned to talking heads.
Okay, and while I'm in IT office, what are you doing in the warehouse?
Well, the difference is you are working on code for big computers, and I'm working on code for microcontrollers and robotics. So this is our laboratory. We built robots here.
Okay, sounds pretty nice.
So another 2 minutes, a minute and a half, and we'll start. Okay.
Yeah, let's wait, everybody.
So did anyone see Ruslan's webinar the last time we did it? I think it was about 2 years ago. Show your thumbs. It looks like you won't be able to base on the previous material. So we'll need to start from scratch.
Oh yeah, like I probably not going to make so deep introduction in the basic to the basics that I did previous time, but still I made as many, like I'll try to make as many explanation as necessary for people to understand.
Cool. I think when we start, you first should talk a little bit about the deduction guides themselves, because it's quite an obscure topic. C++.
I mean, I can spend 10 minutes, like
that's great.
Like about to talk about that.
Oh, okay. We'll let 5 minutes for the people to join. Maybe we shall start.
All right then. So yeah, like a brief introduction.
So let me introduce you.
Okay, fine. I'm fine with that.
here we have Ruslan Arutyunyan, who's the senior engineer in Intel. And he did a lot of, he's also a member of C++ standardization committee. And you may start with a short introduction into your recent projects.
Okay, yeah, so basically I'm working mostly within Intel on 1DPL. This is the library that represents C++ 17 parallel algorithms. Like they have, like we implemented that for just CPU based on like our other library, TBB, and also we have the implementation based on SQL to offload those parallel algorithms for GPU. That's the main thing I'm doing, and also like from the project wise perspective. And yeah, as Sergey said, I'm also a C++ standard committee member, have several proposals being accepted, have several proposals being on the fly, and also, you know, sometimes helping the others with their proposals, either to internal guys or to external guys.
Cool.
And
cool.
and like to share the knowledge. That's why I'm here today.
Sounds really exciting. I'll be helping Ruslan. I'll be monitoring the chat. You can find the link in the Zoom chat. I will send it again in, I think, in a couple of minutes when there will be more people here. My name is Sergey Fedorov. I work for Younger Tech, and I'm the head of a team that's developing robots for warehouses. Okay, so shall we begin?
I think so, yeah. Before jumping exactly to the code, let me just give a brief introduction. Like Sergey already introduced me, but I just want to like basically say some words and agree on some rules. So first of all, I'm not a native speaker, so like that's why my English is not perfect. The second thing, as Sergey said, I was supposed to deliver this talk during offline part of this conference, but unfortunately I was in the car accident and I have several broken bones. That's why unfortunately I will not be able to come in person. We decided to move this talk to online with the organizers. And third thing, like keeping in mind that I have several broken bones, you can see sometimes the pain on my face. So I really apologize for that, but it's not on under my control. Next thing, I really would love to have some discussion today with you guys, but I don't want it to be like, I would like it to be like organized. So if you want to ask something or to say something, I would like to ask you to raise your hand. You can do it with the Zoom feature. Under reactions, it has the feature raise hand. And the Zoom automatically handles the queue of those raised hands. With that, let us get started. Let me share my screen. I believe this one, and I hope you can see it. If it's not big enough, please let me know. I'll zoom it in. But again,
it would be nice to zoom it in a little bit because the font is somewhat small.
Like
yeah,
that?
That's cool. Yeah, cool.
Yeah, if it's bad for somebody, please just let organizers know and they just communicate with me. So what we are going to talk today about basically, I don't have any slides. I really like to have some live coding. That's why we are going to write almost everything from scratch. There's supposed to be a lot of meta-programming stuff because we are going to write our own deduction guides for not so simple like structure, let's say. If you are experienced enough with meta-programming, you might not learn something new today, but again, this is kind of to mostly explain the people that you probably should not be afraid of templates, and like you just should start using those, even if it might be difficult from the very beginning. And like when this task was kind of assigned to me, not actually to me, I helped with I'll help two another guys to implement that, but we didn't know how to solve that. Basically, it took us 3 days from kind of from the point where it was impossible and becomes possible. And let's go through this story. Before actually writing some code, let me just briefly explain the problem statement. We have kind of a really simplified interface here from TBB library, which is threading building blocks library for for parallelization, for concurrency, that has parallel loops, concurrent containers, synchronization primitives, and also flow graph, which is like graph for concurrent execution that you can build and then like run multiple times. And basically this function node is the simplified version of our TBB flow graph interface. There we have also function node. And as you can guess, since it is a graph, the node, like the graph consists from nodes and edges. You can just combine them in the in like whatever way you want. There are some requirements. We have some, static type analysis. So your output from the previous node should be the same or like convertible to the input of the next node, that kind of stuff, and give you compile time error if it's not the case. This is just a brief, very brief description of what flow graph is. And the function node is something that takes a function, and when input comes to this node, like as an object, of course, the function the function is called over this input. So it's better just to say that here we have this one and here we have this one. So basically the signature of the function should be like that. It's exactly one argument. It's of course one output, and then we just call it. It does some things. It's a user interface, so users can pass whatever they want. And then it produces some output and put it further to the next node in the graph. That's the interface. And what we're gonna do is like we live with that interface, like the TBB is previously supported C++ 98. Then we just increase the minimal version to C++ 11, but we still try to support new features and new C++ standard like features as well within the library. And deduction guides like CTAD, which is Class Template Argument Deduction, and Deduction Guides come in C++ 17, and we decided to support this functionality, this feature for the classes where we could potentially. And like I wasn't going to do that, like to explain CTAD and deduction guides from the very beginning, but if Sergey asked me to do that, like let's just try to do that very briefly, just in a nutshell, how it might work and why we kind of need those. So let's for a minute pretend that our function has the only one template parameter which exactly corresponds to something that we have in the constructor. Before C++, and let's pretend that f is not something that is callable just for the moment, and we can pass anything. Before C++ 17, for the classes, we shall always write explicit template parameter. We cannot omit it anyhow, if I remember that correctly. Even if we imagine that it's default, we still
we can just use empty angle brackets. Yeah,
but the point is we still have to use angle brackets. We cannot do like that if we are in C++ 14, but we can if we are in C++ 17. But again, we can just drop it. Not every interface is suitable for adding default template parameters, just not everywhere it works, and there is a good default. For C++ 17, we can do that, of course, not for everything. And here, class template argument deduction, which I'm going to call CTAD further on, helps us. Here it works because there is a very tight connection of what's f is. So basically, based on the constructor, compiler can generate the deduction guide itself that helps it to understand what the type it should substitute here. For example, if it's int and this f is exactly this f, that's why we can see int here, and that's what we see. So it's basically function node from int. And then if we pass double, then we see double right now. But then, like, to have some brief, to continue our brief explanation, let's imagine that it is some f1, which is, let's say, int. And then kind of it perfectly works. So I mean, if we just pass here int and pass here int, here we just have extra template parameter for the constructor, and it deduced like from here, from passing the parameter to the constructor. So f1 is int, but it's a separate template parameter comparing with the class level. That's why they do not tie anyhow between with each other. And compiler, of course, cannot generate some deduction guides, but we, as the class implementers, can write one to help the compiler to exactly deduce this type. So syntactically, it would be some template. Then it would look like the class name, basically like even like the constructor outside of the class. And then it's a kind of trailing return type, but actually it's not. It's just basically here is what call signature would look like, and here is the type it should deduce. Basically, we can say f1, And from now, it should work if I didn't make a mistake. No, it works. It works perfectly. So let's check. Yep. There we go. So basically here we now see double, we can see float, like, sorry, it's a mistake like that. Yep. And let's go back to original problem. We have input and output. And of course, as I already explained, these input and output are not somehow connected with F. That's why we cannot just deduce, like, okay, compiler cannot just deduce input and output for us when users pass some F. So we need to do extra job here. Any questions about problem statement? Sergey, I believe I tried to explain it very briefly,
good.
But yeah, yeah, I believe it's enough for understanding.
Good enough, I think.
So then I guess the problem statement is clear enough. Let's just go further. And try.
There's a nice question in the chat. Why just don't use std function?
Because like this, like, to be honest, I don't know. I believe that with std function, we might have some issues with checking the types at compile time in the paradigm of flow graph itself, how the API was designed. So it just works with nodes, and std function probably doesn't have some properties of the node. As I said, it's a very simplified version of this API. Like it has a lot. Yeah, that's the thing. That's why I think it's the reason why it's not like that. It has much more complicated API. You can look into the documentation. It just provides some hints. It's not like it's the wrapper over the callable object, but plus extra functionality. And I believe this is the case for all our nodes. And also, I also think that this API was even designed when C++ 11 was not there. But that's the latter point probably might be incorrect. Probably C++ 11 was already there. Anything else?
Nope, go.
Okay. So, first of all, the simplest use case with C++ 11, like, yeah, I would like to remind that the kind of contract that we require from the user, that the signature of the of something that is passed here should be exactly like that. So it's a kind of const reference to input and the output. At least that's what our specification, let's say, says. Yeah, but TBB itself supports more than that. We work with output and input by copy, because, like, semantically from the from affecting, like, so we should not change what user passes to us. So either const reference, basically not const reference, but a reference to const data, or just input by copy would be fine. And also we support both callable objects, like functors we call it, and just functions. And with C++11, of course, the nice API we can assume is just allowing to write some lambda, which is like might be like that. For example, we have some f, like some x, and we return x that multiplied, I don't know, by 3.0 for whatever reason. And yeah, we don't need the return type. It just would be, it just would work. And of course, we don't have the deduction guide so far, so we can just write that input is int and output is double because of the conversion. Yeah, and we just thought, yeah, let's try to write the deduction guide function node. And one of the guys who was assigned to this task came and said, it is impossible. We just cannot write the deduction guide for that kind of things because we cannot determine what would be the type of the input parameter, like basically for the parameter to the callable operator of lambda. And that's the place where we can potentially stop our presentation for today and say thanks for everybody, but it's not interesting. And we already recalled that function today. Let's see what that function does with that regard. We just pass the same code. And let's see.
Don't forget to rename it. Okay.
Yeah. Apparently, it works. I mean, it's impossible, but it works. And yeah, like actually, 3 of us kind of brainstormed how to do that, but not like our architect and myself didn't believe in that, of course, and like I had some, you know, vague thoughts how it might be done, but not exact thoughts. But I really didn't believe from the very beginning that it is impossible. That functions kind of prove that. And also there is another case which might give some ideas. This thing doesn't work. We'll talk about this later, why it doesn't, but this thing perfectly works. I mean, for stat function, we can even pass something like that. We can see it becomes double int. It just deduces everything that it needs fine. For us, as I said, it would be just one argument always. If it's not the case, we are not accepting that. And yeah, so since it works for stat function, then we probably should do a better job and also implement that. One of the options might be to go to, let's say, GNU implementation of C++ standard library, LLVM implementation of C++ standard library, and just look how they do that. But that's also not interesting. We decided to prototype our own. And to be there, we need kind of some ideas how we kind of make how we could potentially make it done. And to understand that, we need to understand how to deduce of the all those types and which constructions, which rules of templates could help us with that. So there is a page on CPP reference there, where we started. I hope it's big enough. It's about template arguments deduction. And to be honest, today it's written much harder for understanding, comparing with how it was when we implemented this thing.
Yeah, I remember a couple of years ago, it was much more readable than now.
Yeah, and that's the problem for like today understanding. And I cannot, just click here and let's say, okay, that's exactly what we need. With the previous form of with the previous way of writing it, I just can show what's suitable for us. But even based on that, we can somehow try to brainstorm and understand like what might be useful for us. And let's start from this thing. So it's just T star, so pointer to T. Let us write some function that takes let's just first refresh how things work with deduction, with automatic deduction of types when function is called. This feature fortunately was supported like from the very beginning. And if we just call it with, let's say, some int, we would see it would be an int, like exactly how we expected. But it might do some, more interesting stuff. For example, like this. And furthermore, this is, very broad template, and it means that it can take everything that might be copied. There might be some, let me just put sorry, just vector. Let me just put here stud vector of T, and here we already kind of constrain our function, okay, our overload, that it can only take stud vector from T. And if we, let's say, pass the stud vector to our function, since this overload is more specialized, it would be called. This one, as you can see, even like on the white background, it wasn't compiled, so I can safely remove that to prove that, and like nothing changes. We call exactly this specialized. Now it's not overload because we have only one function, and now it is overload. We have two functions, but more specialized is called. So then we can say it's not vector, it's a template parameter, and say that here we have template type name. Okay, like since C++ 17 they changed the rules, and I can write it simpler without going to parameter pack. Or probably I can't.
You should rename the argument.
Sure. No. Let's just do it again. Here. Yeah.
Okay.
Yeah, you're correct. So and yeah, it should be two type names basically. Because yeah, okay. Let me just write it. Let me just make it like that. Yeah. It's a type name dot because actually our container has two parameters. It's a value type and allocator. That's why it it does not match didn't match previously to this overload, it matches to this one. But the whole point why I'm showing this, it's also more specialized. It says whatever can be decoupled on the template parameter and type parameter. Please just do that and prefer this overload over this one. And that's what we see here. It's the vector. Please pay your attention that it doesn't have type after that in angle brackets. It's a template. It's not a type. The type is stud vector int that we have here. And here is just a template. We cannot create the objects of the template. We can only create the objects of the type. Here is the type. And here it's decoupled on the template and its value type. Okay. Let's try to think what might be useful for our particular task. Let's go back to T star as I originally proposed and have some like yet another function that, for example, I don't know, in double, it has signature int and double, and then just call foo from this function. To just avoid warning. Then what we can see, it prefers our overload with pointer because it's a pointer to function. And the interesting thing is the argument is the pointer to function. For somebody who doesn't know, this is exactly the syntax of the type of the pointer to function. So basically it has return type, it has argument type, and the indication it's pointer to function is the asterisk in the parentheses. And here, this is kind of strange form for somebody who didn't see it before, but it is a function type. So basically, it is allowed that in the code you'll write using func type equal int double as the one expression, and it perfectly fine. It works. It's one expression. It's a type, and that's how it is deduced. And as I said, we don't have it right now, but keeping in mind all of that, we could potentially try could deduce what we need, since it's a function. Pointer to function. We have all of this stuff listed here. We have all necessary stuff here. Let's try to make it like this. Like this, and here we say input, and here we say input, then pointer to function, and the output. Write the opposite, of course. Output is our return type, and input our argument. And there we go. It works, and it works as we expected. So we see like int as the return type, and it goes to like our output. And double is our argument type, and we see it right here. And now it is deduced as we expect. So those are just separate types, and we can use it like for whatever we want. And it kind of probably gives the idea how we can potentially write the deduction guide for the function. But this is probably the least interested part, at least so far. The interesting thing is how to write the deduction guide for callable object and determine its input and output. I probably should make a pause here and ask if there are any questions or any ideas how we can do that. Just based,
please,
just
use reactions to raise the hand if you got questions. There is a question in the chat. What about to reference the function?
It really doesn't matter. So I mean, we can use that, but it's a technique that we are going to use to implement the deduction guide. And as far as I remember, like we can pass bar as the reference to function, and it also would work fine, as we can see, right? So probably somebody sees the reference to functions for the first time today, but still it works fine. But as far as I remember, we cannot do that for member type, like the member types. We should use different syntax there. That's why it's not allowed. But I might be wrong. I'm not sure I 100% remember that.
There is the reference to function is quite mundane stuff. I saw it only in the documents in the references and never came across it in my career. There is another question. Can we do it with coroutines in C++20? Or do we talk only about C++17?
So first of all, yeah, we'll only talk about C++17. I've never thought about that, like, can we do that with coroutines? But I think that we can, because we are talking about the compile time. From the caller standpoint, coroutine looks like just a regular function, as far as I remember. All the magic happens underneath with this, co-await, co-return, and all of that stuff, and the return type itself. But at least we can determine, like, it would be deduced for the output as some future type that is returned by coroutines. It really, like, yeah, the short answer, I think we can. The long answer, I think we should try. And the thing is, it does not matter for the stock at all.
Okay. Looks like there are no more questions so far. Oh, another question. What about boost function traits?
What about those? I mean, they probably exist. I don't know about those. If we talk about TBB, we definitely don't want to depend on boost. We want to be self-contained and do not bring extra dependencies to our users. And also, state function does not depend on boost traits, boost function traits, or whatever they call. And we just
sorry, to continue.
Yeah, and we can just implement everything by ourselves without bringing extra dependencies. So why considering that? Or like, what's the point in something different way?
Okay, there is another proposal to use the signature for the constructor, the same that you use for the foo function in line 19.
It would not work for classes. For functions,
Yep.
it might work. But also not in the way we expect. So I did not say it from the very beginning, but if this function signature, let me just show that. If the function signature is exactly how it's in our specification, so const type ref, then for this function, input also would be deduced as like const type ref, like different order, but the point is the same. From our function node standpoint, we should do that as just double. So we say that even if the function returns const double ref, we are doing here simple signature as int, sorry, as double and int, because it's an input and it's an output. And even for when users explicitly specify this thing, it also would be our requirement. So even if you have this thing and you explicitly pass template arguments, you should write here int, not constant ref, because we need a copy. It just prevents races and all of that stuff. And if we use that idea, here we would also deduce it as the const double ref, not just double. That's why we need to do something more clever.
Okay, I think we can go on.
Yeah. What could potentially help us is this thing, actually. So it's a syntax, not just for the pointer to like function, right? It's a syntax of pointer to member, whatever it is. It can be either a field of the class or it can be function of the class, not static, just like non-static member function. And the reality is, if we add here yet another template parameter and use class here, of course, this doesn't work anymore because it's not a class. We go here, but this is, not the point. We can always change it with, let me just write some callable object. I don't want to use lambda because it would break my flow. So callable, then we use what we did, int operator. Here we have double, and then we have the same return, whatever, it doesn't matter. And try to use basically ampersand, sorry, wrong button, callable what? Callable, sorry, callable operator parentheses. That's exactly what we expected. It's deduced as callable, input, and out. And here we see three separate parameters. We can use only two of those for our deduction guides, but that's what we are going to do for our deduction guides. And let's do that. Let's break our code for the moment. This, we probably don't need this thing. Let's start with writing our own deduction guide. I might make some mistake, but I hope we can easily fix those. We need something clever than just copy paste here with renaming, because we want eventually support both callable objects and functions. All right, so what we need to do, we have some f here, and what we need is something like input type f and output type F. For that, we will write two helpers, which are called exactly like this. And they would ask some structures like helper with F with like just reading input from that. And we also have the same for output. And now our goal is to write this param type where all magic would happen. So let's define that. And what we have, like, it's undefined. So basically it's incomplete type. We are never supposed to go there. We always would expect that if our, not user, our program is correct, we always go to the some partial template specialization that we are going to write in a minute. And also the only way where we go there if F is not something we expect. But for the from our logic perspective, when the contract with user is fulfilled, then we just go to our specializations, deduce the type that in the way we expect, and everything just works fine. We have F as the parameter, but we have also void for the sphenae. We are going to use like substitution failure is not an error techniques, and type name void as the default template, like the template parameter with the default argument is the usual way to do that for the class. And what we're going to do is write the specializations, which with exactly this thing by making those specializations more specialized, comparing like with what we did with functions. Okay, so we probably, oh no, sorry, I'm doing the wrong thing. Here we would have, no, once again, sorry, I'm doing the right thing, but not this one. It's too early to do that. We need to check what we're going to do. Is it good? I mean, if we can do that, if we can write this syntax or not, that's what sphenae is about. I'll explain for like in a nutshell for somebody who are not familiar with that. Anyway, what we're going to do is kind of write F here, and here we are going to write stud void T, which checks if we can do what we are going to do. So basically, let me just leave it like that for a while, and we just would inherit from the param type impl with also something. We don't know what it would be, but with something. And then just use the same technique that we used, the same trick basically that we used earlier. We just have some type, here, and we also are not going to define the primary template. We are not supposed to go there ever. We need to write the specialization, and this thing would be exactly like our function, because we need to split what we want into some parts. And since it's more specialized when it's a pointer to some member, which is function, so basically pointer to some non-static member function, we go exactly to this specialization. So if you want that being matched to this specialization, what should we pass here? And just trying to understand if people follow or not.
Any ideas, guys? F.
No, F is not something we are going to do. Probably the hint is like somewhere on the screen right now.
The suggestion is F operator parentheses.
Very close, but not enough.
FTW is going on. Take the address.
Of course. What was that suggestion? With address or without it?
The suggestion was without taking the address, actually, but later someone added take the reference of F.
Yeah, okay. And now, guys, yet another hint. So basically, it's a value. We need a type. The hint is also on the screen, and
type.
Of course.
Type of that, and you should add another angle bracket after decal type in the angle brackets.
I think I should add angle bracket here.
Yeah, here, right here.
Yes. And also, yeah, like we cannot, like, since we want to support both functions and callable objects, we cannot just take this expression from the functions. Of course, they do not have operator parentheses. That's why we need to check if this expression is what C++ called well-formed. So basically, if it's good, like, I mean, if it can be compiled, and it can be compiled only for objects that have, for the types, yeah, like callable objects types that have operator parentheses, basically public, even public. So let's do that. This thing basically made this expression faceless. So void t always returns void as the type. That's why it's void t. But only if this expression can be compiled. If it's not, it's a substitution failure. But as we know, if we did it right, substitution failure is not an error. That's why, like in our case, it would go here, which is incomplete type, and we cannot like create the object of this type. But if it would be like that, it would be just primary template, and we are done. So kind of this is the something that is more specialized against having operator parentheses within class F. But if not, this is our fallback. As I said, we never want to be here. That's why I'm using the incomplete type, and I don't want it ever being instantiated. But it might be the valid option. So basically, an enable if kind of implemented in the similar way, simpler but similar, that they have, you know, some specialization and the primary template that is not going to work for the use cases of enable if. Anyway, looks like we're good. We basically, let me just put it on the same screen. We kind of check if it is okay or not to do that, and if it is okay, we just pass it to the param type impl, and what we're going to do is inherit from param type base, where we pass exactly output and input, and then we need, of course, this class. Here we are not going to apply any tricks with the specialization. We would just have output, then we would just have input and struct, and we are almost done because
I see you hate the right angle brackets.
I probably
line 12,
hate to do
line
that,
12.
but I mean, I'm talking and writing at the same time. I can always easily fix that. So let's have our output, which we are going to say it's an output, and also let's have our input. All right, everything should work now. We will do some extra modifications to this class, but for now, let's check our deduction guide works. Let's comment that. Let's uncomment that. Of course, right now it works, but it's not a deduction guide. Let's check that. And it doesn't work. And it is expected. Like it is expected. It is the mistake that I made intentionally. But
let's ask the audience.
Any
ideas why doesn't it work?
Yeah, the key thing is it is a lambda. It might give some to somebody some hints.
Add a mutable keyword to the lambda.
Okay, it's too much of hints, but yeah, probably.
Okay, so basically, lambda classes have the call operator constant.
Usually. Yes, by default. Like, was it your answer or?
I started talking about simultaneously with answers in the chat.
Okay, so we need to add const here.
Yep.
And from the function types, okay, not function. From the pointer to non-static member function types. Function with const and function without const are different types, as well as function with volatile qualifier, as well as function with volatile const qualifier. But fortunately, we do not support that, and we not in TBB. That's why we're not going to write all of those.
Other way, you would have to write about, I think, 8 different specializations.
No, not 8. I believe it's 20. I don't forget. I forget how many.
Oh, those are reference qualifiers. Yeah.
Reference qualifiers. No except also, but we're we're not going to.
Yeah, I forgot about no except.
Yeah, so basically, if you if you like
the comment in the chat that no except is also part of the type, yes, that's exactly what we're talking about. That we should have to write tons of more partial specializations to handle no except const, no except volatile const, and blah blah blah.
And L value ref, R value ref, all of that stuff. Yes. So if somebody interested, you can go in CPP reference and see how trait is function is implemented. but we definitely are not going to do that. Like there are many specializations. Let's just keep it. I wanted to say simple, but it's not already definitely simple for somebody, but okay, simpler that it could potentially be. And since now we have the specialization only for const, for non-static pointer to member, which is const, it's not hard to predict when, if we, let's say, have sorry, probably I'm just rushing a little bit. First of all, let's look how our deduction guide is working. So basically, that what happens with us. Let's just check it's the output is correct. The input right now just like deduced as we go, basically, like this. We see here like ampersand without ampersand, like with ampersand, and this signature is prohibited at all. We didn't do any protection. So probably let us just first of all say that we kind of want to decay input. We potentially could use std remove cvref, but it's C++20. Let's just use the decay. It's the simple and short way. And just first of all check that this signature now works, but it should not. It's prohibited. This signature works as expected. We still see int. And to prohibit this function, I would use this trick. There we have static assert with saying that we have to have the is same v for input and input, or we should have the same v for let me think a little bit about that, for const input ref. So basically we try to restore the original decay type and input. Yeah, that's the thing. Let's check that this stops working. It stops, it's compile time error, and we can even look into that. We should see exactly static assertion failed due to the requirement. Let's check that this is continuing working. And yeah, it works as expected, and our deduction guide works. Let's just change the type to make sure it becomes float, and it becomes float.
Well, I'd rather use concepts here, but they are not available in C++17 because the compilation errors here are just ugly.
You know, sure, but concepts are also, like from my experience, not like compilers are not equally support concept today, and
yeah,
sometimes with concepts, you also have some ugly messages, and furthermore, you didn't get used to it yet.
Oh well, I did.
Okay, but good for you.
They're surely not a silver bullet.
Right. So let's then try our callable and see what's going on. We already briefly touched that. It doesn't work because we have only one specialization with const. Like, let's check if we make our operator const, then it should work, and it does. And let's just put other parameters to make sure they are completely different. We can see that now we have char and short. But if it's not const, it does not work. So we need to add extra specialization without that. Cool. Now everything is fine. And also we support 4 variants with const and without const. And here input parameter can be either const input ref or just input, because we wrote this static assertion and this decay. We are probably good, but we did not support functions yet. And as I said, we cannot write this expression for the functions. But we have full power of templates. And we can write extra specialization. Let me copy that. Remove class. Remove impl. Remove class from here. And I think we are done. Let's check. Probably here we should say long. And for example, I don't know, unsigned. And try to use F3 with the bar. And I think like this thing is something we don't need anymore. Let's just remove that and also remove that. Like it doesn't help us. So the latest function node here in the assembly we see is deduced exactly like input for the
sorry, there is a question in the chat. Isn't callable wrong? Deduce other types for the callable, reduce types for the callable wrong. Shouldn't it be short char?
Where? Here? Yeah,
line
I think like
15,
short. Okay, let's check.
Line 15 of assembler.
Line 15 of assembler.
Shouldn't be the other way.
I mean, it is the same. Like it is the same callable. Yeah, let's check. So our input is probably I made a mistake, so it happens sometime, but I think I shouldn't. So basically, it's a for callable, right? So short is our output, char is our input. I prefer in my specialization to write it in a natural order. So output is something
but the
that
arguments for your function node the other way.
Like let me finish again.
Parameters
Probably I'll understand.
Sorry.
Yeah.
Okay.
Yeah. I mean, like output goes first, inputs goes like as the arguments, but for function node itself, the order is reversed. It's just an interface of TBB. I have no idea why guys when they design this API do it in this way. So I think everything is correct. So char is input and short is the output, right? Short is the output and char is the input. It's confusing.
That seems correct. Correct. Yeah, it's confusing a little bit. Okay, let's go on. Looks good.
All right. So we support callable object with const. We can do even this stuff, and it would work. We support callable object without const qualifier after the operator parentheses. And we support functions. But there is a caveat. Before we move further, I would like to ask, like, this is the good time to take a break. I mean, for people to realize what we've just done, to ask some questions, to realize why it works, like all of that stuff. You are welcome, guys.
So you're welcome to ask questions in the chat. You're welcome to raise hands and ask your questions by voice. That is quite unusual for engineers. But let's surprise each other. Maybe we might take a short break. Or,
I mean, probably we should not really. I mean, there is only one trick left. I'll just want to give people some time to have a chance to ask the questions, and then just we go to another problem explanation, do this trick, and I believe we may be done for today.
Oh, okay. And I think the chance is gone. Let's continue.
All right.
Oh,
so
there is a
okay.
Go on.
So you told it to me to go on, right?
Yeah. There was a question about the workshop chat in Telegram. I'll just oops, the wrong link.
All right. I
don't think anyone is interested in the NVIC registers in ARM processors.
Yeah, I understand what you're saying. All right. So, okay. And then this is not the end of the story. We also have one trick to cover. And the thing is, for Lambda, we always have one operator parentheses. But nobody prevents us having overloads within, let's say, struct. We can have as many operators as we want. And let's go back for our stat function and try to have it like whatever, and then just pass. Like we already see that the deduction guide is broken for our callable. Let's just comment it, and then let's just pass callable here. It also doesn't work because stat function does not know how to utilize this information. It sees two operators, it doesn't know which one to take. It sees one operator, and it knows which one to take. With two, it just doesn't work. And yeah, the claim of my colleague, of the same colleague, was, I'm 100% sure it is impossible to do that. Once again, it is impossible. And stat function proves that it is impossible. I mean, stat function cannot do that. But the thing is, stat function is something absolutely arbitrary. It can take anything. But probably, like, I was not sure at that time when I developed that to help with development. I wasn't sure, but probably we could somehow utilize the knowledge that we have exactly one parameter. We are not allowing more than one for this thing. Let's Google and ask address to overloaded function. And we have like some wording in which context it is allowed, in which context it is not. I don't want us to read this. I want us to look in the examples. So basically, when we have overloads, for example, for F, something that can help us is some hints, and those hints might be provided in different contexts. So for example, if we see pointer to function, which is int and double, and we have two different overloads, we definitely understand that if this hint works, it takes this one. But initialization is something that doesn't work for our case. It might be assignment. So, but from our perspective, like, I mean, it's different than C++, but from our perspective, it also cannot help us, unfortunately. We have function, which is G, and here it has arguments where first one is the reference. I mean, it can be pointer. Second one is also also pointer to function, and they can disambiguate those because first one is a int signature and second one is int double, and we know that for the first argument it would choose this one, and for the second argument it would choose this one. And at that period of time I thought, that probably could be helpful, but how to apply this for templates? From the prototyping perspective, what I try to do is before introducing and starting prototyping with all of that complicated stuff, it already works. I didn't want to break it. I thought, okay, let me just, I probably said it too early that we don't need function foo anymore. That's exactly what we need to just have some prototyping, but it's not hard to reincarnate it. This no const. We need to make sure if we pass callable, like our hint here is not about particular types, but our hint is about signature. So you should, like what we're trying to say here is you as the overload, as the function, like as the compiler to match the function against the argument and choose the proper function to call. You should consider only the overloads with one parameter. That's the hint we are going to tell to the compiler. And now it works. Unfortunately, to the best of my knowledge, with templates, I cannot tell any hint to the compiler from the template perspective. Which one of...
I think we can hint it in the calling of the function.
I mean, like, let me first explain. So I can tell it from the, I can say any hint from this perspective because we kind of cannot disambiguate which one is to take, char or double. It's one parameter, it's arbitrary one parameter. It can be char, it can be double, it can be class A, it can be whatever. And that's it. And if Sergey, if like, what do you suggest? I don't understand. Like calling it here within the function?
No. I mean, can you skip to the page that you Googled? There are hints provided to the compiler when taking address of overloaded function, like line numbers, like pass the type of the argument in the parentheses. Let's try it. I don't know if it works.
Which one?
The first one, for example, where you select the F double.
Okay.
Maybe
and what should I try to pass here, and where?
Maybe we should try to do it in line 74. Maybe this is just a silly idea. After operator.
Oh, you say like, okay.
No, not angle brackets, parentheses.
Parent, like I cannot take an address and call the function simultaneously.
You should put the operator, the address taken of the operator in another parenthesis.
But I need this. It's a member to. It's a pointer to member function. I don't have this. I mean, I need.
I know.
Okay, and like where?
Let's try to put the ampersand callable operator parenthesis into another parenthesis.
Okay.
And after that, put parentheses and type double there.
I believe it wouldn't work.
Nope. Sorry.
I mean, yeah. So again,
but actually, you can use those hinting. I think like on that page to create a pointer outside of the call and pass it inside.
Probably, but not in a template context. So I don't understand how to do that. Again, we can just leave it as a homework. If somebody would come up with solution, I would really love to see that. But for now, let's focus on what was achieved. And yeah, if somebody knows how to disambiguate that, it would be great to see that. Anyway, let's go back to this thing. For now,
there is a question: why don't we use decal type?
Here we don't use decal type because it's a function. We call a function with the argument. We don't need type. We're not metaprogramming. We actually do like call with address, and this address just maps to type-wise. It maps to the type. So it's a function. It's a named function parameter. We can give it a name, for example. And here we don't need decal type. There is a place where we need that. But let's first try to like somehow utilize this knowledge, the knowledge that we've just got. Let's rename the foo to, let's say, I don't know, overload deduce, for example. And we need to make it from the style of metaprogramming. So we need to kind of get the type of what deduced by overload deduce. And we are going to use it here instead of just taking the operator parentheses, because we need to deduce that with help of this thing that can give a hint that only consider the overloads with one parameter. And then whatever is deduced by this function, we should pass further to param type impl, so it can just split the three arguments on the output, class type itself, and the input. And eventually we could do that with this thing, naming this parameter, and then whatever is deduced, we just say, return me please decal type name. Name contains exactly this type, which can be further passed to param type impl and split on the three components. Two of those we are going to utilize here. Let's change it and let's check it. So it would be still decal type, overload deduce, call, and call. And here we should do the same overload deduce, and then yet another thing. We break the deduction guide for lambda exactly because of missing const once again. Now it works the same way as we expected. So let's check. Our input is int, our output is float. It's int and float. We deduced here like one function. Our pointer to non-static member function, and we decal type it. So basically we know the type that this function returns, and we are only interested in type. We do not need any body of this function. The declaration is enough. We decal type the type it returns, and just pass it to param type impl and go either here or here. But eventually we should also fix that and say overload without const to actually be able to go here in this specialization. And let us check the results. With these results, it's char short, and that's exactly what we expect. Now we implement it as the hint. As I said, unfortunately, we cannot disambiguate this, or at least I don't know the way how disambiguate this. They exactly have one argument. If no arguments, let's say, it still works because the hint says you should prefer the overload with one. It was exactly one argument. Here we know how, like compiler knows how to disambiguate those. And another observation is it unfortunately doesn't work with auto because it becomes, kind of something similar to template type name T, which is tied to operator itself and makes it generic. And we cannot take an address of the generic of the function template without instantiating it. That's why this trick simply doesn't work. Another interesting observation here that unfortunately adding any of template functions with no matter how many parameters, so basically you can say double and then t can be deduced. That's something I don't understand, to be honest. There should be explanation, but I don't understand. We cannot take the address of these operator parentheses. That's for sure. That's kind of something that I can understand. But at the same time, we have perfect candidate. We can take address from, and like it exactly matches. And compiler potentially, from my understanding, would do that and just take an address. But unfortunately, if not go into any short meta programming logic that we just did for our deduction guides, we can just take everything away, just write simple stuff with callable, and then just operator parentheses. It as far as I remember correctly, yeah, it even does not work with simple case, even with, as far as, like, I might be wrong, sorry, but I might be wrong, but I think even with simple case like that, even if we give a hint. So callable, then what? Then something like that. I hope I'm not lying with syntax. And then, sorry, here we should not have int, we should have short. And here we should have char. Here we should have some name and like that. Okay.
Bum.
with exact hint, then apparently it works. If trying to write template variable, I believe it's still okay. Yeah, it's different. It's different. Yeah, let's not get deep into that. But again, from my perspective, it could potentially disambiguate that, especially this overload has two arguments. It's never the case it would have only one. That's something I cannot explain, unfortunately. I'm sorry. But yeah, besides that, if we just remove and that, I don't know, whatever. Remove template. I think we are good. And everything just works as we expected. We can look here and see like that everything is deduced as we expected. I think I'll share the link to this Godbolt so everybody can play with that and like experiment and try what works, what doesn't. And I also have some homework for you guys. If you want, you can try to write the deduction guide to extend this implementation with the deduction guide for overloaded functions. We cover overloaded callable objects, but we did not cover overloaded functions. There is a way, but I'm not going to tell it right now. If there are any questions, you are welcome to ask. I would be happy to answer if I can. But from what I wanted to share today, that's basically it.
That was a cool talk. Please go forward and ask questions. Raise your hands and raise your voice. Anybody? I saw Pasha Filonov joined us. He might ask a question.
I think we have some hand raised.
I don't see them.
Like
someone
Ariad,
unmuted.
If I read this name correctly, so
sorry, it was not raised hand, it was just celebrating the great talk.
Okay, I
Thank
see.
you very much.
Yeah. Okay. It's a clapping, basically.
Okay, I see that Kelban unmuted. You want to ask them something?
Sorry, I missed start. Do you use reuse as a function deduction guide or not?
No, of course not. It's like for like probably like
no. I mean as a function already has a deduction guide, so you can use deduct guide and of it create deduction guide and write will be as a function x value type or something like.
We, like if I understand the questions correctly, so we should like to make deduction guides workable. We need to. Okay, let me state it differently. Reuse where in metaprogramming. Sorry, in.
Можно по-русски просто.
Yeah, okay. You can ask Russian. We will translate it for the other audience.
Эта функция уже имеет deduction guide, и таким образом можно и внутренний тип функции. Таким образом можно справа в Deduction Guide написать SED function, ну, то есть decal type, SED function, function type внутренний, и таким образом убрать из кода Callable traits полностью, разобрать ее Deduction Guide, который работает для всего, для чего возможно в C++.
Okay, let me try to translate the question. So basically, like I believe you can even explain it, you know, in English. That was my question, like where we're supposed to utilize the deduction guide of stat function, and the idea to write it here and just then read the type of the stat function that it deduced. All right, that's the nice idea. Let me just quickly Google that. I'm not sure. I want to check one thing, just quickly. So, oh, anyway, I think you're probably right. So yeah, it has result type. It doesn't have it has argument type, but it's deprecated. So we potentially could utilize that or could somehow deduce
we
it
can
from
template the function.
Yeah, I understand. So we can potentially utilize that, but it would not work for the last context that I've just described, where we utilize the advantage of knowing that input should be exactly one. That function, as I've shown, cannot deduce it from this callable, but we can.
Okay. Thank you.
But you actually can add this constraint for one argument and reuse a stud function.
Probably no. We still cannot, because as I shown, it doesn't matter about constraint, right? It's stat function just cannot do that for us. We cannot.
You first check for constraint for one argument and after that call stud function.
Again, we have two overloads, right? And these work for our deduction guides. If we constrain with our arguments, what we're going to do, how we shall constrain that, we need to somehow extract the type of the operator to check if it has one argument or not, right? And we cannot do that because like ampersand doesn't work without hints.
Okay, maybe I will need to think about it.
Again, this is my understanding at this moment. We can discuss it, for example, offline, but I believe it would not help.
So any more questions? Looks like we shall call it a day.
Fine with me.
So thank you very much, Ruslan. Thank you everybody for coming. And if you have something that you don't still understand, if you've got questions, please feel free to ask questions in the Telegram chat. I'll repeat the link once more. And see you on Saturday on our conference.
So just one note, like I should put probably the link in the chat, right, where we have all of these guys like to play around, and also like what I was going to say. Yeah. Anyway, thanks for coming, everybody. Guys, I wish you a good conference and Saturday. Unfortunately, I will not be able to be there. And if you have, some homework to share that I just asked you to do, so I believe you can also put the links in the chat, right, Sergey?
Yeah, sure.
Mm-hmm.
That would be great. Okay.
Thanks, everybody.
Thank you. And have a nice evening.
Yep. You too, guys. Thanks. Bye.
Bye.